Hi everyone. Hope you're keeping well and you had a good Christmas and Happy New Year. And it's a shame we're back on video, but sure, hopefully it won't be for too long. Right, so same as we did during the last lockdown, we're just going to keep going. We need to get through as much content as possible, and we've done really well this year so far to attempt to catch up on last year. So we'll just keep ploughing on. Excuse me. The chapter we were working on before Christmas was the higher level functions chapter, and I kind of got through enough of it so that you'd be able to make a good attempt at the exam. But I hadn't fully kind of wrapped it up to the point I was happy with. So I suppose I'm going to call these lessons kind of finishing quadratic functions today, and then we'll do finishing quadratic or exponential functions. Yeah, we have to finish off exponential functions as well. So maybe 2 classes and we'll get this completely wrapped up. I'm probably being generous there. We probably don't need 2 classes, but that's what we'll do. Okay, and then we can move on from functions. It's also a good opportunity, I think, because we had the break, that it'll almost feel a little bit like a revision. Sorry. Functions is one of the hardest chapters, especially at higher levels. So it's no harm kind of spending 2 days this week doing a bit more functions. Okay? Right, so how are we going to do this? So the notes are going to go up. So I'm clearly using... Hopefully it's clear. I'm using your OneNote here. So the notes will appear in here as normal. In order for me to have lessons up at 9 a.m, I have to do them the previous day. So I suppose try and stay with the videos, because it will get very confusing if people are working ahead. There's no need to work ahead. Okay, just stay with the videos. It's just I can't possibly have like 6 class videos recorded before 9 a.m. on a given day, so I have to I'm always a day ahead. So I am sitting here recording this on Sunday so that it's ready for 9 a.m. on Monday morning. Okay, so you'll obviously have this video. I'll put the video into the OneNote, so obviously, you know, you can play it as many times as you want, pause it, whatever. You'll have access to the actual notes like as if we're in class, so they'll obviously appear up here and you'll have access to them. So I think the videos worked really well last year. I mean, even the bits we've touched on for algebra and stuff this year, you got a really good grasp of it, considering I taught it to you by video. So, I mean, I think the videos work quite well. You know, I sort of, when I think about how this works, all you're really missing is being able to ask me a question. Right? So, what I'm proposing is, see up here in the collaboration space. So I'm going to add a page. I'm going to do this every day. As in every day we have class. Why won't that work now? So I'm going to add a page, if it will ever let me, to the collaboration space. And I'm going to call it the same name as the video. Okay, so I said this was like finishing quadratic functions. Okay, I'll type that whenever it works for me. So essentially what I want you guys to do then is, when you're watching the video, if you think, oh, I have a question, then I want you to go into the collaboration space, and if I could ask you to type your question into the collaboration space, and hopefully then I'll have a series of questions typed, and depending, like if there's 2 questions, I'll just it depends on the nature of the questions. If I can answer them by writing answers, I will. If I need to make another video to answer your questions, I'll do that. Okay, so I just think this might give us like another dimension to what we did last year, that you might be able to answer. Now, I don't know if this is going to work, but this is what I'm suggesting. Okay, so as you watch the video, if you think, ooh, if I was in class, I'd put my hand up there, then pause the video, go into the collaboration space and type in the question you want to ask. Like, it might be a very easy question. It might be something like, oh, at 3 minutes in the video, you said this. What the hell did you mean? Do you know? It doesn't matter, right? Whatever the question is, and I'll do my best to bring you answers to all of them. Right, so we're going to do that just as a kind of an addition to what we did last year. Same as last year, I'm going to give you homework. Now, I'm not going to give it in a separate document because you can access everything here, so there's no need to. So I'll give you your homework. And then just like we were doing in class, you're going to, like, it doesn't really matter, we'll use Aaron's. So you're going to put your homework up in the homework section. Okay? Now, I need you to put the homework up one page at a time because I'm not going scrolling through pages. I just don't have time to do that. I have too many people's to check. So say for tomorrow's homework now, oh my god, this will not work at all. Hang on, let me try. Is it that? There you go. So, what am I calling it? Finishing quadratic equations and the 11th of January. Okay, so that's what that's done for Aaron now, so that's what he's going to call that. He'll either, I know some of you are using Apple Pencils and doing your work directly into your iPads, which is fine, or if you're doing it in your copy, take a picture and put it in here. Alright, so each day you'll have a different page, and I want the title of the page to match my video, so I'll have no problem finding it. Is that okay? I mean, the way you add them, kind of when you add them chronologically, like if you add another page there now, they should go one at a time. So I should always just be checking the last one, but let's make sure they're, you have headings on them, so it's as easy as possible to find. What I'm going to do is I'm going to check 5 or 6, as in I'm going to check and correct 5 or 6 every day, and then everyone else's I'm just going to check that it's completed like I would in class, and then I'll check a different 5 or 6 the next day. So your work will be actually marked by me, like what, there's 20 odd in the class, so probably once a week, maybe once every 4 classes, something like that. Okay, right, so that's it. So that's the plan. I'm going to email you the work, so the link to the video. I'm going to email you that at 9 a.m. on the day you would have class. So for you guys, that's Monday, Wednesday, Friday. So at 9 a.m. Monday, Wednesday, Friday, you should receive a video about maths. Your homework is due by 9 a.m. on the next day. So for example, today's homework, today being Monday the 11th of January, the homework for today is due at 9 a.m. on Wednesday. Okay, so I'll go in somewhere between 9 and 10 because obviously I have a few classes to check, but somewhere between 9 and 10, and I'll go into each folder and make sure the homework's done. If it's not, you will receive an email from me to say your homework is incomplete or not submitted. Make sense? Let me know if there's any questions, but hopefully that is okay and we'll get started. Okay, so I just wanted to do a couple of these quadratic functions that I kind of flew through before Christmas, so no harm getting a little bit of extra practice. So we had done linear functions, we did quadratic functions, because I know you did this one here, because we have it marked, so this was homework at some point, so we have done quadratic functions. I suppose there's just a few things we didn't get to that I wanted to make sure that you could do. I spotted this here, which is tricky, and there was something in this one. Anyway, we'll do this one. So the function g below gives the approximate distance of a jet ski from O'Connell Bridge at any time during a 10-minute trip. Okay, so remember that the name of this function is g, the input is x, yeah, and the function itself, the bit that we're actually concerned with, is minus 10 x squared plus 50x plus 500. Okay, they give us the domain, and if you remember, the domain are the x values, and they tell us that the domain, and remember this symbol kind of, oh, what's the word I'm looking for, this notation is the word I'm looking for. This notation means going from 0 to 10. Yeah? G of x is the distance in meters from O'Connell Bridge. So the first question there, straightforward enough. Draw the graph of the function, g of x, over the domain 0 to 10. Okay, so I'm going to try and do this. So I'm going to get my calculator. Okay, I think you're good with doing this. So we're going to press, you press your menu setup button, and then you press number 3, see it's here? You press number 3 for a table. It's not mode, it's menu. So you press the menu setup button, you press number 3 for a table, and then you have this. Yeah, that pops up in the corner. So now what you want to do is put in your function, which was complicated, and can I remember it? Minus 10x squared plus 50x plus 500. Minus 10x squared plus, so minus 10x squared plus 50x plus 500. Okay, so to put that in, you're going to hit the minus first, yeah? Then you're going to do your 10, so 1 and a 0. Next you want is the x, so that's where you do alpha button, and where's the x? This button here, the bracket. Yeah? Then we want it squared, so you put your squared button. Next thing is a plus, so go down to your plus button, type in 50, so 50. Next we need another x, so we're going to go back for alpha and back for x. Then back to your plus button down here, and then 500. Okay, so just let me put that in my own calculator. So minus 10 alpha x squared plus 50 alpha x plus 500. Okay, when you've all that done, you press equals. Now, when you press equals, it pops up this. Sorry, I think it's equals. So if you had a second function to put in, you could put it in now. You don't, so I'm just going to hit equals again. So hit equals. And now I'm looking at this thing. Do you know this start end step thing? Okay, so this function was to go from 0 to 10. So that means my start is not going to be minus 3. My start is going to be 0. So I type 0 and I press equals. My end is not going to be 2, it's going to be 10. So I type 10 and I press equals. And I want to go up in steps of 1, so I leave that unchanged and just press equals. Okay, so now my table has popped up and I'll tell you what's in it, and hopefully you are looking at the exact same thing. So for part A, my table is 0 with 500. 1 with 540, 2 with 560, 3 with 560, 4 with 540, 5 with 500, 6 with 440, 7 with 360, I'm just using the arrows to move down to get all my additional, 8 with, what's that, 260, 9 with 140, and 10 with 0. Right, so I need to find a scale here. Go up in 50s maybe? What do you think? 50s might work. No, not that. This. I don't need a cross like this because I've no negative value, so I only need this one. So that should be a bit easier. And I'll take... No, that's not going to work. Sorry. Get rid of that. Try again. Okay, so I'll take as much space as I can there and see if I can fit in going up in 50s. So 51, 52, 53, 54, 55. 556. Yeah, that'll work. Let's try that. So that's 50, that's 100, that's 50, that's 200, 50, 300, 350, 400, 450, 500, 550, 600. What is that? That's a distance, isn't it? In meters. And then across the bottom, I need to get 10. 1, 2, 3, 4, 5, 6, 7, 8. No, we just have to go. We just have to go in one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. And that was a time. They all represent minutes. Okay. There's my graph. I picked a suitable scale and I've labelled. So let's try and put my numbers on now. So 0, 500 is 0 on the minutes axis, which is right in here, and up to 500, so that's there. 1, 540, so there's 1, and 540 will be just before 550, so about there. 2, 560, that's going to be the other side of 550, right there. 3, 560, in line, there you go. 4, 540, so that's coming back under the line. 5 is back to 500, so that's back down on the line. 6 is 440, so that's just under 450 here. 7 is 360, so above 350. 260 then for 8, where is that? That's down here. 260 for 8. 9 is 140, so that's going to be under 150, and then 10 goes right back to 0. So that's what we have. Let's try and get a bit of a freehand curve going through that if I can. Okay, so that's what my graph looks like. Use your graph to estimate the maximum distance the jet ski is away from O'Connell Bridge during the 10-minute trip. So because we had this double 360 thing, I'll try and delete this now. We had this double 360 thing going on here. Do you remember the way it has to be just above that? I don't know that I've drawn it extraordinarily well, but let's see if I can fix it a little. Let's see. Try and get a bit of a smoother curve. Okay, that's a little bit better. So if I zoom right in, okay, in order to curve and to keep a natural curve going, you have to go up here in between the 360s. Okay, so I don't know if it's going to let me do this so heavily zoomed in, but this hang on, I'll try it again. I might need to do a freehand. I'll try one more time. So this is the maximum. Right, you can see where I'm trying to point. I'm just going to do a freehand. Okay, so the maximum distance is like here, and we're just going to come straight across. Ish. Yeah, you get the idea anyway. So I probably dipped a little there. So if this point here is 550, it's probably 575, I would say, as your maximum height is 575 meters, which makes sense. 560 was the recorded max, and then it goes a little bit behind that. I can do a little. Is that 2.5? Hang on. I can tell you what the actual answer is if you bear with me. Plus 500. So the answer apparently is 562.5. There you go. That's what it should be. But we're doing it obviously from our graph. You need to do it with a natural curve. Yeah, so you do the best you can. Okay, and my arrow, because I dipped a little, I think it is about 575. But whatever your arrow points at when you do your natural curve, it has to be above 560 though, that's the key. Okay, and part C, use your graph to estimate the amount of time the jet ski is 540 meters or more from O'Connell Bridge. Okay, so 540 is not the best one ever because there definitely probably was a better scale I could have picked, but anyway. Okay, so 540 is around there. Yeah. So that line represents 540, right? So there's 2 points here and here where it went like here, it went above 540 and then it stayed above 540, above 540, above 540. And then at this point there, it went below 540 and it kind of stayed. Okay, so the question was, use your graph to estimate the amount of time the jet ski was at 540 or more. Okay, so it went more than 540 at this point, which if you look, kind of follow the line down here, that was at 1 minute. It went above 540. This one here, when it came back below, if we follow the line down, was at 4 minutes. So approximately how long was it above 540? Approximately 3 minutes. Okay, and it does say estimate. Okay. So that's actually very similar to the ones we did before Christmas, so nothing major new there, more just a bit of a recap of some stuff. And then the other one I want to do is this one. Okay, so use the same scales and axes to graph the functions g and h. So we have two functions. We have the g function, so that's the name of it. The input, as always, is x. It changes sometimes, it's rare though. And then the function itself is minus x squared plus 6x is the function. Right, so if I was in class, I'd ask you to talk to me, about that function. So it's what type of function? Shout at the screen, I swear I can hear you. So it's quadratic, which means it's a curve. And then the fact that it has this minus at the front means it's the sad face curve. Okay, so that's what that one's going to look like. Well, obviously not that, but something like that. And then the h function. So h is the name of the other function. Excuse me. The input is x. And then the function itself is 2/3 x plus 1. So then what type of function is that? So we have no squared there. So that makes it linear, which means it's going to be a line. Yeah? Right, so I have the two functions. I have a domain, here it is here. So it goes from 0 to 6. So I'm going to go back to my calculator. I'm going to press my menu again. I'm going to pick table again. Now, obviously, the calculator always calls the first function f. So that's obviously our g function. That's just the way it is. Okay, so I'm going to type my minus. I'm going to go alpha x. I'm going to put squared and then plus 6 alpha x. Hit equals. Okay. So now what I'm looking at on my calculator is g of x equals. Do you remember I said if there's a second function and you have a second function, you can put 2 in one just to like save you a bit of time. So you can do these, do this one and get your range of answers and then do this one separately and get your set of answers, or you can do them all in one. Okay, so I'm going to do it in one. So I'm looking at the moment at my, I'm looking at my calculator. I'm going to clean this mess up. Okay, so I've just put in my f of x, my first function, and now the calculator says g of x equals. So normally here we just press equals and keep going. I'm going to put in the second function here. Okay, so I'm putting in 2 over 3 alpha. I moved to the right and then I did alpha x, and then it's 2 over 3, what was it? Plus 1. Plus 1 equals. Okay, So now I have both of them in, and I have the start end step page up. So my start is 0, which I'm getting from here. My end is 6, which I'm getting from here, and I'm going to put steps of 1 equals. Okay, so now what your calculator should show, this is obviously gone now, is you have one column which says x, then you have another column which says f of x, and then you have a third column which says g of x. Okay, now remember this one is our quadratic function, so that's the answers for the quadratic function, and this one is our linear function. Okay, the names are all mixed up because you can't change the names in the calculator, but that's what we put in. And then down the side here you have your 0, 1, 2, 3, etc. And then you have your answers. So for f of x, my first answer is 0, and for g of x, my first answer is 1. And then I have like 5 and 1.6666, something like that. Okay? So essentially what I have here is two tables. So I'm going to write them down separately. Alright, so over here, for this one, I have 0, 0, 1, 5, 2, 8, 3, 9, just going down, 4, 8, 5, 5, and 6, 0. Okay, and the other one then, so go back up to the top and look at the other one, and this time my 0 is paired with a 1. Now, my 1 is paired with a 1.66666, right? But that'd be a pain to put on a graph, obviously. But the fact that we know this is a line, I don't need 6 points. I actually only need 2. So I'm going to skip all the awkward ones because I don't think I need them. If you look down, right? See 3. 3 is a whole number. The answer when you input 3 is an output of 3. And is there any more just for... There is. The last one, 6, gives me an output of 5. And like I said, to plot a line, because it's a line, you only need 2 points. You only need to join 2 dots and then you have a line. So I don't need all those messy decimally ones. So I'm just going to use it. Is that alright? Again, we have no negatives, so I'm not going to bother with them. So I'm going to pick my XY graph. Put this down here. I should have more than enough space here. Don't have any real awkward numbers here. So I'm going up to 6 on my x-axis. So 1, 2, 3, 4, 5, 6. And that's my x-axis. And then on my y-axis, what's the biggest number there? It is there. So 9. I think I have 9 there, do I? 1, 2, 3, 4, 5, 6, 7, 8, 9. We go to 10, so we're not right. So 2, 3, 4, 5, 6, 7, 8, 9, 10, and there your y's. You can write every number in if you want. I don't know, I feel it kind of looks messy or something, so I don't. Okay, so I'll stick with my colour code and I'll start with the red ones. So 0, 0 is going to be right here, otherwise known as the origin. 1, 5 here. 2 8s here. 3, 9 is your max there. 3, 9. 4 8s is here. 5, 5. There, and 6, 0 is there. Okay, so it's quadratic. Actually, as predicted, look, it's an upside down or a sad face quadratic. So nice, smooth curve if you can. I'm trying to get my last off, not bad. Okay, and then we'll switch over to green. And we'll put in our 3 easy points. So 0, 1 is here. 3, 3 is here. And 6, 5 is about there. Yeah? I'll zoom out so I can try and get a line in. Okay. Okay, so not ideal, but it's pretty close. I'm kind of off my dot here, and I'm off my dot in 2 spots. But anyway, it's fine. All right, so there are my 2 graphs. So using the same scale and axis graph the functions g and h. Actually, I should label them. So g is the quadratic one, and h then is the linear one. All right. Okay, so use your graph to estimate the value or values of x where. So for part A, it says g of x is 5.5. So this isn't a question about the g one, the red graph, okay? Remember that if they put the 5.5 in here, it's an x value, but when they put it as an answer, so see the way it's an answer, it comes after the equals, that means it's a y value. Okay, so we are going to go to where y is 5.5. Again, see, can I get a few arrows in without it jumping all over the place? So 5.5 is there. Okay, I think I'm alright. Oh, it's a bit low. Okay, I'll try that again. 5.5 there. Okay, that's a bit better. Yeah. Okay, and there's 2 values, so it's here. So okay, so I can't get all the way down. It's so annoying when it does that. And then the other one, we'll just get rid of that. So can I do it again? Can I extend it maybe? No. I seem to have absolutely no control over it. Okay. Giving up. So we have to go from this point here, and you're going as straight as you can. You guys obviously use a ruler, which is what I was attempting to do. So we drop down. So 1.1, and then this one over here. Again, try and keep it nice and straight. And maybe 4.8. So sorry. Nearly there. So 1.1 and 4.8. So then the other one, the next one, sorry, is here. So it's h of x, which means it's my green graph. And again, they've given me the answer equals 3.5. So they've given me a y value. So I'm going to try again. I might go into this color and go to 3.5 on the y-axis. So there's 3. There's 3.5. Yeah, again, it's a little low. I just can't. If I zoom in, it just won't work at all. So it's a little bit low. But anyway. So what we're talking about then is same thing. Drop down. So that's about 0.7, and then over here drop down, and that's about 5.25. Okay, so 0.7 and 5.25. Okay, next I'm going to need other colors here. We're getting there, nearly there. So we'll go purple. So where does g of x equal h of x? That's where the graphs cross. Okay, so my original graphs cross here and here. So again, you drop down from that point. So that's about 2. And then you drop down from here. That's about 5.1. Okay, so 0.2 and 5.1. Alright, so that's all stuff we've done before. That's called interpreting graphs, where, you know, you're just reading what's over here, putting on the graph, and then tracing down to see what the answer is. This one is a bit different. Okay, it asks you where 2/3 x minus 1 equals 0. Now, if you look, it's similar to h of x, but it's not the same. Okay, 2/3 x minus 1 is not the same as 2/3 x plus 1. Okay, so what you do with these are tough, right? So we take our 2/3 x plus 1, which is our h of x, and we have a graph of it. And ask ourselves, how do we go from 2/3 x plus 1 to 2/3 x minus 1? What would I have to do? Okay, what you have to do is minus 2. Okay, I'll do the sum and then I'll take it away again. If you did this now, you have 2/3 x and plus 1 minus 2 is minus 1. Yeah? Okay, so what you have to do is take h of x and minus 2 to turn it into this thing here. So if I take 2/3 x plus 1 minus 2 off it, I get this yolk. And then according to this, it equals 0. Okay, so essentially what I've done is I've taken h of x, right, which is 2/3 x plus 1. I minus 2 off it, and I have to figure out what values of x will make that equal 0. So you basically do a little bit of algebra on it. A different colour. You have a minus 2 here, so you do plus 2, and that will cancel, and you do plus 2 over here to balance. So what you're actually looking for is where is h of x equal to 2. Okay, and again, 2 is after the equal, so it's an answer. So I go to, I need a different colour, pink. I go to 2. I'll get one more arrow in here. So I go to 2. And, oh, that works absolutely perfectly, like, stop. Okay. I think I've just realised I did one of them wrong, but I'll come back to it in a second. Okay, so I go to 2, and I go across, and remembering that this question is about h of x. H of x is the line, so I'm looking for where that has crossed the line. So my big pink arrow here crosses the line. Where's pink? Crosses the line here. So we drop down, and that's at about 1.55. Okay, so that one is tricky. There's a little bit more to that now. Just scanning through there. See the second one, B? It was a h of x question. So I went to 3.5, which is here, and I drew the gold arrow across. Okay, but what I did was, look what I did. Let's go back to my gold. I figured out where the golden arrow crossed the G graph. But that wasn't the question. Look, I was meant to be doing the H graph. So let's just fix that now. I don't know if I'm going to be able to remove this, but I'll try. So we don't actually care about this. Okay. So we don't, this line here, we don't actually care about, or this one. Because this question was h of x equals 3.5. So what I should care about is the h graph, which is here. Drop down. Okay, so that's actually 3.6. So sorry about that. So this is not right, and the answer is 3.6. Apologies if you were shouting at me the last time when I was doing it. Yeah, so just obviously when you draw in your lines, just make sure that you're connecting with the right graph. The first one was the curve, the G graph, but this one should have been the line. All right, so anyway, that's just a bit of work on interpreting graphs. So for homework, which is due for Wednesday, I want you to do question 3 here, and I want you to do question 10. Okay? So question 3 and question 10 for Wednesday. Okay? Let me know if there's any questions.